Hello, everyone. How are you today? I appreciate you guys coming in on a Saturday. Uh, all right. Are you guys all pumped up for today evening? Are-
Yay!
That's good. That's good.
Today we will talk about AI in healthcare and explore its potential together. We will deep dive into the technicalities on various topics. We are excited, and aren't you?
Are you guys?
Yeah,
All right.
superb. But still, we feel that energy is a bit low. Let's, Sana, what do you say? Is it right?
I think we should do a quick full body energy checkup.
Absolutely. So let's divide this group one and two. Once I say one, just raise your hands and say yes with a stream. And when I say two, this group should do the same. Okay, so let's start.
All right. Scream as loud as you can.
Yeah. Group one. Okay. Group two. This is
It's
a bit
too bit
louder.
louder. You guys need to scream a little more louder.
No worries. Still, I mean, still, we can just have a try. One more time. Group one. God, this is
Oh, good.
better.
This is
Group
nice.
two. It's equalizer now.
It's
It's matchable.
equalized. It's matchable.
That's a great job.
All right. So, welcome to yet another GeekyAnts meetup. This time we are covering AI and healthcare. This is the first in person healthcare meetup. We have done these in the past, but they were all online. So, moving on.
In case you are wondering who we are, I'm Prem.
I am Sanna.
We are from social and community team, and we are your host for the day. Here are our social handles. You can just follow quickly here.
I go by
Yeah.
Sanna Bara.
And Prem Goswami 07.
So, if this is the first time you're attending Geeky Ants or visiting Geeky Ants, let me tell you who we are in a glimpse. We are a product design and development studio that turns ideas into reality. We are community-driven first company, and we focus on tech stacks as React, React Native, and Flutter. We have also built some amazing products. You might have heard about Native Base. We are the math scientists behind it. And we have very recently launched our another open source product called ClueStack. It's a universal UI library tool. It can be used for any industry. We have used it in a few of our client projects and we have seen good results. So you can give it a try, do check it out. Additionally, we are a very active part of tech and business community. We host a lot of meetup, such as this one, and our leaders speak at global conferences, events. For example, recently we hosted our very first international meetup in London, where we had the chance to meet few of the Amazon folks. And you can find more of those stories on Geeky Ant's Twitter handle and on Instagram page. Apart from all of that, in a nutshell, we love building tech communities along with building relationships. So let's move on to the agenda for the day. We have a really amazing line of speakers. They are from Carelon, Cure.ai, GE Healthcare, and WebNot Technologies. I will let our keynote speaker delve into those kind of details.
Yes, and here we go right now. The most important part of this meeting, that is code of conduct. Do not use any hate speech and inappropriate comments. Keep it light. Be respectful and refrain from using strong words. This is a space for growth and learning. Promote that. Get to know your fellow attendees and speakers. Network is important. Keep your questions for the panel discussion and maintain silence while speaking speaker is giving their talk. But yes, one very important part, whenever the speaker will come on the stage or whenever the speaker will finish their talk, we should stream, guys, and as much as they can.
Yes, we should also clap, okay?
Yeah,
Just cheer them on.
because they deserve that, because after a long thing, they need motivation finally.
Yes, they do. All right, so let's move into the most important thing. I know you guys might be wondering. Connect to Wi-Fi name. It's GeekyAnts guest. The password is GeekyAnts capital G capital A at guest capital G 2023. Or you can scan the QR code quickly. I will wait for a couple of seconds
Yeah.
until you do that. Just give me this when you're done. Do you want me to zoom in on the QR code?
Yeah.
Is everybody done?
Done.
All
Over to
right.
Sana.
Thank you. All right, so let's get this event started. To tell you more about where we are with the AI in healthcare industry, I would like to introduce you to our keynote speakers for the day. Pramada Sahu, she's the CPO of GeekyAnts, and Priyamvada, she's a software engineer here at GeekyAnts. She has been experimenting with AI and has some really great insights to share. So let's let me help me welcome them on the stage.
Hello, everyone. Before we get started with this much awaited healthcare meetup in AI, I quickly want to ask you one question. How many of you have tried that gesture control assignment that we have put there? Has any one of you tried? Can you raise your hand? Okay. So, Prem, note for you, nobody knows that there is some project, okay? Please ensure people should know. Okay, so this is one of those gesture control project that we have done. This was basically done for the physically disabled people who have like very less motor skills. So with the help of the sensors, they can gesture and they can do their daily course, or if they want to play any games, they can use that. Do try that gesture control project that we did. It was a short trial for the physically disabled people. Okay. First of all, thank you so much for joining in today for AI in healthcare meetup. Today, I'm going to talk about mostly around what we have been doing. We have Priyamvada. I am going to be first welcome everybody, and I'm going to be your keynote speaker for the day. Before we delve into the groundbreaking reality of artificial intelligence and healthcare, I want to tell you that today we are just not going to talk about technology. It's about how we are changing the life of a human. How hospitals are actually going to use these AI models to help deliver the better outcomes. uh, yeah, technology is certainly one part, and we have other speakers who are going to talk about this. Uh, Welcome everybody on board, and we have. So I wanted to put across a very important thing. Right now, we have patients' genetic information. We have X-ray reports. We do have there all the information available, but doctors are not able to take the right decisions on the right time. And with the help of these AI models, we are actually able to predict the diagnosis right, give the right treatments to the patient, and also have a better prognosis for the patients. Welcome, everybody. Uh, and I am going to be a keynote speaker. As I said, I have Priyamvada, who is our AI expert, and she is going to share more insights around what GeekyAnts has been doing. Let me share a small story with you. Ram, who is a cancer patient, he has gone through various comprehensive clinical assessments, and also he has gone through imaging assessments. But to be honest, doctors are not able to find out where his primary cancer site is. But with the help of right now AI models and AI tools available in the market, doctors are these AI tools are empowering doctors to find out where is the primary cancer site is. Now actually doctors know that what is the treatment we have to go. Before it was there that we know that the patient Ram has a very less chances of survival, but with these AI models we can give the right treatment on the right time, and that's how it is empowering doctors very well. And these AI models can actually expand exponentially to give the better decisions and better output. So that's where AI is standing. So why AI and healthcare? We have always been talking about artificial intelligence as a very negative aspect of it, right? But today, my colleague and myself and other speakers are going to tell you how it is going to transform the lives and what is the future and the impact of healthcare and what is the way forward. So why AI? It is actually giving us the efficient diagnosis. It is helping doctors with the precision medication. And also, as I said in my case study, that is, it is giving the right decision support at the right time. During the COVID, we have realized that how remote monitoring, where patient is sitting at their home, doctors are giving the right information about the patient and they are able to take the right decisions in the right time. With these AI, it is certainly going to reduce the cost of a hospital, and hence it is reducing the burden, the operations burden for the hospitals. Okay, so as we move forward, I am very, very glad and excited to welcome all our speakers who are the thought leaders in healthcare and technology. We have thought leaders and companies from Cure.ai, G Healthcare, CareLawn, Webnot, and GeekyAnts, who is going to share their insights about how the AI in healthcare is going to look forward. Uh, so I'm going to pass on this mic to my colleague Priyamvada to talk about what GeekyAnts has done and what is the evolution of healthcare and AI in health.
Thank you, Pramada. Let's start our exploration with understanding the evolution of AI in healthcare. AI started its journey in healthcare in early 1970s. At that time, it was basically used to automate administrative tasks. That time, AI was not that intensive and not many people were doing AI tasks. If we move fast forward to 2000s, it has made remarkable changes in its technology. Now we are using machine learning and deep learning methods to understand data and based on that make diagnostic accuracy. Oh, this one. Now, and in the 2000s, when we see what all big events were happening, IBM Watson started making headlines because of its impressive accuracy in diagnosing rare diseases. At the same time, CRISPR, I think, yeah, CRISPR came, which helped with genetic analysis. It combined with AI and with it helped in medicine with genetic engineering. Sorry. This happened and AI became personalized. This started the era of personalized medicine in AI. If we come to the current state of AI, it has evolved significantly. It is working in drug development, radiology, and virtual health assistant. If we talk about virtual health assistant, we already know about natural language processing. Big companies like Google's Gemini, OpenAI, these are the leading companies which are using natural language processing and large language models to create a very nice virtual health assistant with huge data amount in which you can talk and personalized chatbot you can create. We are using machine learning and deep learning to create breakthroughs. A person can include their medical history and medical data and start interacting with them at this point. Now comes the main point. What GeekyAnts is doing in AI healthcare. We have already done some small projects, 4 or 5 projects we are already done, and some are being deployed as well. Let me explain some of the projects that we are doing. The first one I'm going to talk about is Fitness GPT. It is a GPT powered AI app that we have created. It helps give personalized recommendations based on your inputs of diet plans, calorie counts, and exercise recommendation. It helps with macronutrient counts as well. The second app that we created, it was Indian currency identifier for visually disabled. Our Indian note does not have a braille printed on them. So for that purpose, blind people are not able to use easily the currency. For that, we created a small custom trained classifier. It was based on object detection techniques and computer vision techniques. One more we created, talk with the medical documents in natural language. This was a chatbot in which any person can go, include their medical history and upload documents and start interacting with them to gain insights. The best part about this app was there was no problem of data leakage and data privacy. The biggest issue that AI in healthcare faces is of data security. For that purpose, what we did, we hosted our own large language model on which, based on which this chatbot was built. We have an NVIDIA GPU, which we give user access, and anyone can host their own fine-tuned model based on that. Now comes mental health support app. This app we created for people to go and give their location as well as a disease name, and it can tell us about information about that problem, coping techniques, helpline numbers, and also nearby locations. But one ethical issue came again here, so we had to find a stopping point at this app. Here we did not include a professional person, and as we know that gpt is not much reliable when providing information, we needed to include a professional therapist or psychiatrist for this app to be launched. So this is at stop right now. We will continue when we can include more personnels. Now, coming to continue with that challenges and ethical considerations, as we talked about data privacy and security issue. As I was talking about the chatbot that we created, we are hosting our own large language model. We already did that for a few of our clients, and it is working very nicely because there is no data privacy issue. Big companies always have sensitive data which they do not want to leak. So everything has to run on local. We are already achieving that, and that is a very nice project that we are doing. Next is bias and inequality. As we know that large language models are trained on huge amount of data sets, and those data sets are obtained from internet mostly and sources that include bias. Based on that, the large language models also learn the bias, and it comes in our chatbots and models which we use in AI for creating chatbot. Transparency is also a very big issue because right now the AI models we use is kind of like a black box. No one knows how the training is happening, and for that reason doctors are unable to completely trust the diagnosis created by the AI models. For that purpose, transparency is also very important. There are many other ethical issues which we can get into, which I am sure other speakers will also get into.
Yes. So we have seen that there are challenges and ethical consideration while we talk about AI, especially in healthcare. And certainly, we all need some kind of risk assessment or some kind of analysis that can limit these kind of challenges. And of course, AI can be used in a better form. As I initially said, AI is always been going to be on the negative side, but how AI can put up things where we can have better healthcare delivery. So I'm going to open up this session for all our speakers and talk about how AI in healthcare is going to have better healthcare delivery and better outputs for the doctors, where we can transform the life of a human. That's very important. Moving on, I'll pass on this mic to Sana for the next speaker. Thank you.
Thank you.
All right. Huge round of applause for Pramada and Priyamvada. Thank you. All right. I think it's time to bring forward our first speaker for the day, Rejesh Bose. He's the Director of Programs and Partnerships at Cure.ai. He has been in the healthcare profession for over 7 years now. So let's hear more from him.
Hi. Hey, hello, everyone. Thank you. First of all, I would like to thank GeekyAnts for organizing this event and inviting me. So happy and so happy to see some very young faces, very excited to know about AI in healthcare. So just a very brief intro about myself. I'm Rejesh Bose. So I work as a director of programs and partnership at a company called Cure.ai. So Cure.ai is an Indian healthcare AI startup. We work predominantly in AI in radiology. In the beginning, the team Priyamvada was mentioning about this, how the cancer screening was done with the help of AI. So we are one among the organization who work in cancer screening, along with other anomalies in the healthcare and AI. So just going ahead, we'll deep dive into the other aspects of it. So it's like, it's just talking about AI is something, it's always conceived very differently, right? I mean, you go and tell to anyone you work in AI, people see that what comes to their mind is sometimes a robot doing surgery or something like that. So it's always, AI is something, I mean, still it's a concept. It is not something not very solid like a car. You say car, everyone understand what's a car. So AI hasn't reached to that level. It's still a concept for everyone. And whenever you say you work in AI, the way healthcare, the bureaucrats, the government, everyone conceives it very differently. But virtue of human intelligence, we had philosophers who thought about AI in 1950s itself. We had one of the definitions coined by John McCarthy about AI, that saying it's a science and engineering of making intelligent machines. Yes, we are in 2023. I think we are going towards making those machines, those technologies, which makes human life easier, which is making more impact in the human life. So this is like something, since I mean, I'm sure that I am not a tech geek, but still, I mean, just want to start with what, like, giving the, like, all the AI models are worked out on machine learning and deep learning. We also use, so Cure AI. We work very actively in very active R&D team, and we have developed our products. After very deep learning and algorithms we have used, and we have more products in the market currently. So just going ahead. So just to connect why AI is needed in healthcare. This is something that, like, why healthcare? I mean, unlike like every other domain, healthcare is also something that where there's a huge demand of AI. One reason it is operationally huge. You take any hospital, any government medical college, or any private hospital. The kind of operations happens in a hospital premise is huge. It starts from giving a nurse, ordering a drug. It's like taking an X-ray, managing the OPD, so managing the consultations, making the fee, the supply chain. So the operationally, it's a very huge premise where there is a lot of things to be, a lot of activities, lot of aspects needs to be automated. So AI has a big role. AI has a lot of scope, not much more than what currently is there in the market, but there's a lot of scope. And as I said, there's a lot of, it also involves huge amount of data, and the data which healthcare deals is, it's more sensitive, more more uh, patient confidential data. So that is also one thing which makes healthcare little riskier, as well as there's a demand to it. So that is also one reason our need of AI, why there is a huge need in healthcare. Then definitely, as you know, it's all burnt out workforce. So what AI is trying to make is the life easier, the lives easier by making an impact in healthcare operations and the healthcare delivery. So that for that, I mean, companies like Cure and a lot of companies are taking a front head in that. And it's also something that universally scalable. So if you have a technology, if I can match the regulatory metrics to the countries, and the healthcare is universal, we can scale it across the globe. That is also something that makes healthcare an area to dive with AI. So there are existing solutions, as you all know, and some of them are like there are very core solutions in diagnostics. So diagnostics, whether it is in pathology, whether it is in radiology, there are many AI organizations currently working across the globe, which includes in India. In Indian companies are there. There are in ECG, EEG, X-rays, digital pathology, biomarkers. It goes on. So medical research, remote monitoring, personalized medicine. Personalized medicine, it comes where every the genetic aspect of it, every patient data, everything is measured, and the health and wellness aspect is given back to the patient, like Healthify Me does, or like multiple products has that angle of personalizing healthcare, is also a byproduct of AI. So yeah, AI is also, like as I said, like as Priyamvada was mentioning in the beginning, there's large language models just like ChatGPT. We are trying to build things in AI, but in healthcare, but due to the confidentiality, due to the nature of healthcare, it's not something like not all the informations can be applied on ourselves. There's a lot of lot of concerns around that, lot of regulations around that. So, but still, it is a model which is being worked across the globe, and we are expecting a lot many large language models coming through AI in the healthcare domain. And digital pathology biomarkers is something that we have in place, but yeah, looking forward to more products, because cancer screening and identifying these biomarkers actually makes an impact in quality of patient life, and also in the time, that healthcare time is something that matters a lot. If a cancer or something is screened today or screening after 5 years, makes a lot of difference in many people's life, and also financially, as well as it is making a difference to the patient, to the hospital, to the community, to the globe, everyone. And yeah, as I mentioned, hospital operations, like we always talk about AI on a patient angle, but there is a lot of scope to do with the hospital operations AI, which most of the hospitals, you take Apollo, Fortis, all of them are friend diving those their own product. They are partnering with different organizations, but hospital operations is something like, since there's a room full of scientists, I'm just telling there's a lot of scope for the AI products in there, especially in supply chain operations, even in the HR. Hospital is one place where there's many human resources are being managed in a single day, which start from housekeeping, nursing, to the doctors, everyone. So there's a lot of scope for that as well. Then insurance, yeah, it handles a huge amount of data, and there's a lot of delay in insurance claiming, whereas also where large language models and the AI models can add value in the healthcare aspect. So these are some of the AI health use cases which AI can do in healthcare, which you all know, but just want to highlight few of them, which is helping with reading X-rays, CTs, to developing vaccine, processing huge data from health records. Health records is something most of the hospitals has actually digital data, but just digital data is not actually utilized to the full potential, though it has its own confidentiality and regulatory aspects. But if there are models which can make benefit to the patient and to the hospital with this data, that is something can be thoughtful, and there are organizations currently working in it. And this triaging of patients with the help of chatbots and early diagnosis of disease, all these things, I mean, we have a lot of scope for the AI. And yeah, just repeating, I mean, the personalizing the treatment, hospital operations, going at potential target for drug sensitivity tests, epidemics, lot of things. I mean, if you like, healthcare is something that's very vast, where there are lot of scope for AI to do in healthcare. So just like going into what we do as an organization, what is Cure.ai doing, and how are we impacting AI community. I'll just go through it for a very briefly. So we work in predominantly in the domain of radiology and AI in radiology, to be very precisely. And the mission which we are right now is there in making healthcare more affordable and accessible using the deep learning. And we have like the regulatory aspect of healthcare is something that we seriously take, and we have all the needed clearances, FDA for United States and the CE for Europe, and Indian clearances, and every country has its own regulatory landscapes. And we have done that, and we are right now, we are impacting around more than 5 million lives on yearly. And we are also recommended by World Health Organizations for screening of tuberculosis in certain settings. And we have a team of 200 plus people, and this is our global footprint. We had a great impact. We have deployed across the globe with around 80 plus countries we go. And I'll just go a little faster this slides, because it's so we have a very interesting product portfolio, but still the focus is more given to the X-rays and CTs. So we have product where we can you give a chest X-ray, take a chest X-ray. Our AI built product can read these chest X-rays and also detect diseases including lung cancer, lung nodules, lung malignancies, opacities, consolidations, tuberculosis. It goes on, around 30 findings we can find from a chest X-ray. So same with, we also the critical neuro cases can be screened with the help of AI. Though think of a situation where there's a doctor is not available. So where AI gives the AI triggers, AI triages, AI notifies the doctor, so that the without the doctor being physically there, so the treatment goes on. The patient is getting benefited. So things are moved to the next step. So that is what we work in head CTs. So, and also we have a product to spot fractures from the musculoskeletal X-rays. And we are also having lung cancer screening from chest CTs. So right now, as a company, we are currently focusing on the radiology aspect of it, and we have AI product which is currently working in radiology with all these use cases which I mentioned. So I'll just quickly walk through few use cases which our product does, and also connect it to the AI in healthcare landscape. So we have same product which works in different use cases. So why it is important is you take so suppose from chest X-ray we can read tuberculosis and lung cancer. But tuberculosis is a disease, you go to United States, UK, the prevalence is very less. So when a product needs to be globally scalable, it has to have understand the geographical aspect. So something that make more sense would be in a different settings or different geography would not be tuberculosis. It would be lung cancer. So it's very prevalent in the US market and the Western market. So more than tuberculosis. So in that market, that's where our product use case fits. So when it goes to tuberculosis prevalent countries, including India, Latin America, or some places in Africa, and the focus would be the use case would change. So that is something AI can always think through. That is somewhere where like any product we make, we have to have universally, we have to do the you know the customizations and the kind of something that the product itself has should have the capability to scale across the geographies. So that is something that we need to be mindful. I mean, this is just telling about our product. We have around 6 use cases where we work. We can one of our product can screen tuberculosis, lung cancer, heart failure. It can be in ICU settings. It can be used emergency rooms. It goes on. So I was just taken an example. So this also brings to the situation that like how AI model is built. As we all know, the data is the data is the background or the foundation for AI. So when you want to scale it up, we also want to make sure that the data contains a geographic aspect of it. We cannot make a model with only having data from India or somewhere in Bangalore, and we cannot scale it. So that is also somewhere the importance of data, importance of universal data becomes important, because then only the product will make sense to the geography and the community it has to serve back. It has to serve. So just putting, I mean, like health system, I mean, is as a whole, like the whole as a whole health system, how AI is impacting in from my experience is mainly on clinical aspect. As we all know, it's the patient is getting benefited. The patient a disease is screened or identified or diagnosed a couple of days earlier means always his quality of life increases, the chance of curing increases, the chance of better life, everything gets increased. So there is a direct patient outcome with the AI and the direct clinical outcome. And also the the hospital aspect of it. There are chances for misinterpretation or misdoubt readings. So that is something that always AI does. AI does that double check. So something when we go and talk to the doctor community or the medical community, we make sure is we always take the stand. AI is not there to replace the doctors or not to act as something not to replace or not to compete with them. It is instead it is AI currently, and every time I think AI has to complement the existing health system and make the result more more impactful. That's what we do, and that is what in every aspect we are trying to do. Even if you look at the economics angle of it, so there is a long term benefit to the state, to the country. Suppose an AI product is saying that today we are screening tuberculosis, and out of 1,000 X-rays we did, 70% of them are not tuberculosis. So that means the state, usually it's a government, has to do the TrueNet, CBNet test, which is usually expensive for the for the beneficiaries. So when AI model is saying with high precision that this is not needed, so in turn it is actually saving the cost from a health system. So that is the economic angle of it. So every product, even if it is a minor thing, like even if it's aspecting all the regulatory aspect and doing the right validation, it can make a big impact, and that impact is actually universal. So now like I had an experience in implementing AI in Indian health system. So it's not always as a cakewalk. This is something that I want to again highlight. We think of implementing AI and going ahead with our products, but when you go and talk to the communities, so there's lot of confusions and concerns around the data confidentiality. So everyone, I mean, everyone thinks that you are there to data when the product. So that is something that misconceptions, that something need to be clarified, because healthcare data is end of the day, that data is entitled to the patient or to the respective person. So we or no one can take it and make a model out of it. So there are ethical ways to it. We have to procure from the ethical sources and do the thing. So when you go and deploy any AI product, any AI company, this is some challenge which they are facing, especially in large scale involvement. The concerns about the data needs to be it may be you may have all the regulatory confirmations, regulatory aspects, but still people may not be understanding it in that sense. So those sort of communication, those sort of conviction to understand, that is something that's a reality check which I had during my AI implementation experience in 2021 and 22 I faced. And the regulatory landscape is also very tough. If you go to any country, I mean, if you take Thailand, Vietnam, every country has its own local regulatory aspects, and you take the FDA aspect of it. So in US market, which is the biggest market, without FDA nothing can be ran, and these are very tricky, long term, and very exhausting process. So that is also something when we think of AI implementation, building AI products, something we need to be mindful. And FDA is like, though it's an US thing, I mean, wherever you go, if the product is FDA approved only, you will get that the sense of accepting it. So there's a lot of such concerns which we need to be mindful and which we need to work towards it. Then another thing is hardware and infrastructure. Not everywhere. I mean, even if there should be a minimum internet or uh, minimum infrastructure we required to run a machine. Not in low and middle income countries or countries like India. Like, let's think about beyond Bangalore or beyond metro cities. Not everywhere we have the enough infrastructure to run it continuously. So that is also some challenges we are facing. So that makes you scientists make the tech community to build more products, more hardware agnostic, and which can run in very less infrastructure, less tech infrastructure. That's also some angle to think through, some thought for the day. And the business angle of AI scaling up is, it's not having the universal use case is very important. The use case should be like, whatever it is we are doing in the healthcare, it should be it should be something making sense to the whole healthcare community, and nothing can go on its own. It needs strategic partnership. That's where which it is needed. So maybe, I mean, any company, we may need to work with pharma companies, medical devices, going ahead, educational institutions, researchers. So those sort of partnerships can only build or make a product its own, having its own address. So those strategic partnerships will something impact and something that going to influence the growth of these organizations. And as I said, there's a relevant use cases. Though the product can do wonders, but we need to understand which use case works in which geography better. That is also something to be mindful. And healthcare is very, very empirical, very evidence-oriented, domain. So, like, though you say your product can claim screen lung cancer or screen heart failure, but that is not enough for the healthcare community or to be get the acceptance. So we need to have the enough academia, enough researchers, enough working to come, enough ground truth validation should come from the actual real time deployments, and real time learning should come. So yeah, and just to and something also very behavioral thing is, there is a regular workflow, regular aspect. There is everything is going on already there. So when you go and impact, say that AI can add value, this value is not known to someone already. So you have to do it without disrupting the existing operations or existing workflow. That is also something that no one wants to do. Even to like, not even a data entry, and no extra job is not anyone is appreciating. So that is also an angle that we need to look. The product which we are developing and sending out the market should not have a stage of adding extra work to the user. So that's the very thin line. Without disrupting the existing operations and workflow, this product needs to get embedded in their actual ecosystem. So the way forward thinking, I mean, there is a scope to massive scaling up. The technology is booming. Companies are there. There's a lot of VCs, a lot of funding, a lot of AI is, as you said. I mean, I think 2022 must be an year for AI. Post-COVID, we have heard about a lot of companies within India and across the globe has come up. And whatever the proven solutions, radiology is one of the proven solution in AI healthcare. Strengthening, those proven solution is something that the policy level decision we need to come from the governments, from the bureaucrats, which needs to come from. And there is a lot of regulations. Still, AI cannot sign a report or cannot do anything. I mean, because on its own, it's still structured or still linked to the the conventional angle of it. So those regulations, how those can be eased out, how those can be made more more beneficial to the AI community or the tech community, that is also something to be thoughtful and to be combined. Needs to have those efforts happening at the ministry level or the policy level needs to have happens. And also more like, just like GeekyAnts is doing, having that research collaborate mindset. So that sort of support and making people calling in one room and talking each other and learning and unlearning from each other. So that sort of support is also going to add value, I believe. So just running a little fast due to the slides. Just want to do justice to the time. So yeah, just to conclude, so there is a lot of scope. AI can assist to deliver better clinical care. AI can become mainstream in clinical care delivery soon, and it also definitely increase care coordination. The way which we communicate has changed over the years. So now coming in with AI, the healthcare communication is going to again multifold impact is going to come with the addition of AI into it, and also patient outcomes. So end of the day, healthcare revolves around the patient. I mean, the ultimate beneficiary is the patient who walks into a hospital. So that patient outcomes is also something that AI is going to add value. The moment patients start receiving those direct benefits, then it will not be a community, or it will not be something driven by the tech companies. It will, this request or this demand or this interest will come from the public itself. Yeah, so just to add, the idea of AI is to make lives of patient or the users or the doctors or the hospital in the healthcare setting to make it comfortable, fast, and precise. So that AI have the capability, and we are into that directions. And with that, I'm just posing here. I couldn't walk through all the slides, so like very the tech side of it, my fellow speakers will be deep diving into it in the later sessions. But with this, I'm ending my session. I know I went a little faster, but just wanted to have as many as thing. And I'll be here if anyone wants to connect or to know more about what we do, or just for anything on anything that I'm happy to help, happy to network. Yeah, thank you.
Thank you so much, Rajesh. Can we all give him a round of applause again? Thank you so much for that insightful and very detailed talk. We are going to call upon our next speaker for the day. It's Kousick. He's the CTO of WebNode Technologies. His talk is about neural networks. So we are very privileged to have him here on stage today. Come on.
Check, check. Thank you. All right. Just bear with me, guys, one moment. All right. Okay. Hello, everyone. Thanks for having me here, Pramada, and the team, GeekyAnts team. Thanks so much for having us here. It's really exciting to see all of you in the arena here. Talking about AI in healthcare. It gives me immense pleasure to talk about few topics that actually enable AI and machine learning and deep learning in healthcare. And for tech folks like us, it sort of enables us to go beyond what we are doing right now and sort of do what we sort of dreamt of in the past, right? So I'm going to talk about deep learning, neural networks that enable AI initially, and then we'll sort of talk about a little bit of aspects into the healthcare, right? So okay, the very first thing that I want to tell everyone is the growth in the deep learning industry, right? And what has sort of enabled this, right? So you see the graph here. There's a dip in 2000, and then there's a steep curve, both in traditional ML algorithms and in deep learning, right? And why has this happened, right? This has happened because of the compute power that we have, right? So we all have seen how cloud and cloud computing, has grown other parts of technology since early 2000s, and when AWS and GCP and other cloud vendors, sort of
gave a breakthrough. And this compute power is what has helped researchers and data scientists to sort of put what we had on research papers into reality and practical solutions. And henceforth, we've seen a lot of research papers. You know, how do you gauge growth in machine learning and deep learning, right? It's basically based on research papers and publications, right? And based on scholarly from Google and a bunch of other research paper platforms, there's an increase in publications in terms of deep learning and ML algorithms. And this is a very good positive sign, because there are a lot of people who are working on different research papers, different aspects of ML and deep learning and neural networks to sort of solve different problems in the world, right? So this compute power and the lot of amount of data that we are able to collect today, because of the storage capacity that we have, and the advancements in instruments and devices, and the type of data that we can collect, this has enabled growth in deep learning and machine learning as well. Now, Priyamvada also did mention that AI in healthcare started in around 1970s, right? But deep learning goes way back in 1943, when a couple of folks sort of coined deep learning or neural networks. They said it could be possible on how a human brain sort of performs, a computer or a system can perform, right? They sort of did this with electronic and electrical circuits, and it was mostly left at a research paper, and then it was picked up and implemented as a perceptron as the first one, right? Now we have neurons and neural networks. Perceptron was the first one that came out, and it was Frank Rosenwald who sort of did that, and that was a very big breakthrough, and people started believing that deep learning and ML can really have some potential in the world tomorrow, right? So eventually, as we move through the timeline, in '98 we had CNN and LeNet. CNN is a neural network which sort of again gave a breakthrough in computer vision and vision analysis. And the bigger breakthrough was when AlexNet in 2006, they sort of uh, created a groundbreaking module on top of CNN to sort of analyze images and sort of predict what the image is, or sort of understand what the image has and come up with results, right? And then it grew from there. Google sort of came up with their own neural network called GoogleNet, which is on top of CNN, which we'll talk about, right? And then it kept growing, right? And today we are with GPT and a bunch of large language models, and now there's no stopping. There's a lot of people working. So what we're saying is it's not what is common today. It's not new. It's been there since history, and people have been working around. And like back then, it was research papers. Now it's it started putting into real world implementations, right? So what is deep learning, right? So there are three parts to deep learning, right? There is an input layer, or a neural network. There's an input layer. There are bunch of hidden layers, and there's an output layer. I'll give you an example, right? Now, what are we trying to do with deep learning? We are trying to mimic what a human brain does, right? So what happens when a piece of ice is placed on your arm, right? First is the perception of, having an ice on top of your arm, right? And then your neurons sort of connect and tell you that you're feeling cold, right? So this connections of neurons that sort of first understand, which is the input layer, and the neurons that sort of connect and sort of pass information between each other, and then tell you that, okay, I'm feeling cold, which is the output layer, right? So this, in a very layman term, is how deep learning works, right? Now you'll always have a question on how deep learning is different from machine learning, right? So deep learning, okay, first machine learning, we've seen a lot of things. There are aspects to learning at the computation level, right? So there's feature extraction. Let's say you have some data, and let's say you have an image or a bunch of tabular structure. Machine learning expects you to extract certain set of features, put it in certain set of formats, and let the computer learn it, right? While deep learning, the neural networks, the way people have built it, it sort of learns on its own, right? It's basically mathematics. It's basically mathematic equations with a bunch of weights and equations, functions, and different aspects to it, which sort of make it happen. But the difference is deep learning is a lot more intelligent to sort of understand. You need a lot of training data. With a lot of bunch of training data, it sort of understands what input you have and what is the expected output. Probably it might not say, let's say you train it with a cat and a dog. Probably it might not say that it is a cat and it is a dog, but it might say that, okay, this belongs to this classification and this belongs to Y classification, right? So that's the power that deep learning has. Now, I'll briefly touch a little bit about components of a neural network, right? So I told you, right, there's an input layer, there are a bunch of hidden layers, and there's an output layer. What are these bunch of hidden layers, right? These hidden layers, I'll take an example, right? So let's say this is the image dog, right? And what do you tell the neural network? The neural network, you tell that, how do you identify this being a dog? If you were a human, what would you look at? You look at its nose, you look at its ears, you'll identify it's a Labrador based on its ears, right? Maybe a Doberman based on its tail, right? So it's a similar fashion that deep learning also performs, right? You sort of tell, or the neural network sort of learns, sort of breaks the image into different aspects, gives itself weight. For example, for a dog, the nose has more prominence, right? So it assigns a weight to it. Let's say out of 1, let's say 0.6 is given to the nose, 0.2 is given to the eyes and the ears, right? So this is how it sort of understands that, okay, this is how I need to train myself, right? Now what happens is, once this information is given to itself as different input layers, let's say you have 3 different characteristics of a particular data, there are three different input points, and these input points are then converted into something called as weights, right? So there are multiple layers. The more number of layers in hidden layers, it's known as deep learning, deeper layers, right? So when it reaches 1 layer, it sort of has a bunch of weights, sort of understanding, okay, I'm looking at the ear, and probably it looks like a Labrador. I assign a weight to it, right? And I move to the next layer, right? That's how it sort of tries to assign weights. There are functions called activation functions, which sort of decide whether an input from one neuron is passed to another neuron, and what action it has to take from there, right? So those are activation functions. There are 3 primary activation functions that we generally work on: is linear, we have sigmoidal or tanh, and then we have rectified linear unit. These are variations of them, but these enable the neural network to sort of understand and move forward, right? Now, what happens, like we spoke about this, right? So neural networks are not always right. I told you, it sort of learns by itself. How does it learn by itself, right? There are various techniques. I'm going to talk about just a couple of them, right? So what happens here, right? So an image is passed, and it sort of first tries to predict it based on the different parameters that are available, and it predicts that it is a dog first. It fails, and it goes back again. So the first so the first thing that happens is called a feed forward approach, right? Where it sort of tries to understand the image, goes through different neurons, and comes up with an output. When you sort of tell the training model that this is not a cat, sorry, this is not a dog, this is something else, it sort of goes back. It's called a backward propagation. It sort of adjusts the weights, adjusts the type of functions that it has to use, in sort of trying to make itself better and better. So more the training data, it sort of understands by itself that it sort of needs to adjust its weights, the activation function that it uses to sort of come up with a better result, right? So now, why deep learning in healthcare, right? Now you look at the right side here. It's a heat map which sort of covers the availability of experts as in radiologists and pathologists across the globe, right? You see the green portions. You have enough people around the North America and Australia region, but there's there's shortage and there's lack in most part of the world, right? Now this opens scope for technology, automation, AI, and everything in healthcare, where people can jump in and sort of build tools around that space, be able to sort of describe how a disease like what Rajesh spoke probably, how diseases are identified, more faster ways of identifying diseases, and so on, right? The second is we have loads of data today, right? We have we have health records of patients, which sort of help us understand and come up with predictive analysis, being able to understand reports, diagnostic tools that are far more better than before, which sort of push in data in a more faster way, and a more can give us more accuracy, right? So that these are things that enable us as data scientists and people who work on deep learning, machine learning, and AI to work on healthcare as well. Now there are two prominent neural networks that I'll be talking about today, which and I'll also be talking about how they're applied in healthcare, right? So there's something called as, this was invented a lot earlier, and it's called CNN in the local terms, but it's the convolutional neural network, right? So convolutional neural network, the highlights are it analyzes images in terms of understanding, like he said, X-rays and reports, and sort of come up with probably what it can give you out of that report, right? Now why it's doing good is the accuracy is high. It's either equal or even better than clinicians and specialists who are looking at reports. And it outperforms the speed at which a clinician can look at report and come up with results saying, okay, this person's got cancer, this person's does not have cancer, right? So how does convolutional neural network work, right? So it sort of takes an image. Now let's consider this image. This is not a grayscale. This is a colorful image. So in general, colorful images are broken into 3 frames, R, G, and B, right? And all these different frames are, produced into a matrix, right? And these matrix are then, different filters are applied, like, for example, weights. These filters are applied, and then there's something called as pooling, which sort of downsamples this to a more sort of what I need to look into the image, right? And not see everything else, right? So it does pooling, and then it sort of flattens this into numerical data so that it can be pushed into different layers of the neural network, right? So that's how this sort of understands how to analyze an image, get it trained, and be able to give results to clinicians and specialists, right? Now I'm going to talk about a specific case study by Google, right? So there are 415 million people who suffer from diabetes across the world, right? And there are various side effects and problems that occur due to diabetes, and diabetic retinopathy is one among them, right? Now, Google, in partnership with Arvind and Shankara hospitals in India, they did this setup where, why did they do this? Because India is in short of 127,000 eye doctors or ophthalmologists, and every patient who's diabetic needs to get screened once at least a year, right? So sort of help this process, they sort of built a neural network with CNN and sort of trained data. I'll talk about that. But what happens if a person is not screened, right? If it's categorized between 0 and 5. 0 being you don't have diabetic retinopathy, but 5 being you're about to lose your vision, right? And these days, if you don't get this screening done, there is a 50% chances that you have a vision loss, right? So what did Google do, right? They had 150,000 fundus images that take a photo of your retina, right? And this was provided in association with Arvinda and Shankara hospitals, and they hired 54 certified ophthalmologists in the US under Google, and they labeled and they identified 880,000 diagnoses in these 150K fundus images, right? Now, after doing all of this, they put it into execution, right? How did they do it? GoogleNet, which is an implementation of Google's CNN framework, they have something called as the inception module, with which they sort of implemented this, and the accuracy was about 95%, right? And the false positives were around very minimal, with 8 false positives in one bundle of data, right? So that is one pretty good case study on how neural network and deep learning, specifically CNN, was applied in healthcare. And organizations, big, huge giants such as Google, are investing and partnering with people across the globe to get this done, right? Now, I'll talk about the next one, which is a recurrent neural network. Now, CNN, being a convolutional neural network, it sort of analyzes images. It's into computer vision technology. But recurrent neural network sort of is, for most sequenced data, time series data, sort of understands how it understands the context of what is happening, right? So RNN is applied outside healthcare in NLP, where for example, you're writing an email on Gmail. It sort of predicts what your next 2 words could be, right? It's because what your previous 2 words were, right? So it is T minus one, right? You're writing something now, there's a T minus one information that has been fed in, and then it predicts what is T plus one, right? So that is what a recurrent neural network does, right? It is used to analyze sequential data, ECG reports, EEG reports, and text sequences, that clinical people, write, right? Now, how this works, pretty simple. Like I said, there's an input layer, there's an output layer, and there's hidden layers, right? But the additional thing in layman words is it also takes T minus one input from the previous set of input, right? So that's how it's able to, predict for that particular context and that particular use case, right? So I'm going to talk about one such case study called Dr. AI. It was done by Jimeng Sun and team. They had written a research paper. And what did they work on, right? So they worked on predicting clinical events, right? Like I told you, right? Recurrent neural networks sort of understands what happened before and what's happening now and what can happen in the future, right? This is, so what did they do? So they took records of people visiting clinics. There's visit one, visit two, and they were able to sort of predict visit three, right? What could happen, right? Now this prediction also, predicts the timeline at which something can happen, and also what can happen to a patient in visit three, right? So how did they do this? They sort of categorized. I'll go to the numbers. Okay, so this is a disease prediction modeling, and they had 260,000 patient records from Starter Health, records spanning over 10 years of timeline. 38,000 codes used. Now these codes are, diagnosis codes could be fever and cough. Medication codes could be IV fluid and X-rays. IV fluid and giving them a shot or something, and procedures could be X-rays and MRIs and so on. So that's how they sort of diagnosed and coded them. There were 1,183 output labels, and the results were far better with a recurrent neural network, right? Now, the results were around 70% accuracy. Now they sort of compared this with, traditional way of predicting diseases and clinical prediction. So RNN did a far better job with, more than 70% of accuracy. And the others are pretty straightforward logistic regression. It's a regression model. And then most frequent is based on the most frequent visits and the type of diseases that appear. And last visit is based on a last visit. You sort of predict what you're going to have next, right? RNN did a very good job in that aspect, and it was wonderful from what we've read. Thanks to that, and yeah, that sort of ends what I wanted to talk about neural networks. There's a lot of depth in it, which we cannot cover in a day or a two session, because you have to sit, write equations, do maths that we did not want to do back in school, and sort of get it done, right? So what does this help us in healthcare, right? So it can predict things that doctors can't predict from imaging or analysis, increase the accuracy of diagnosis, and more accurate results in less time. right? That ends my speech. Thank you so much. Thank you. Uh, so I just wanted to mention one thing that we are doing at WebNot is we're working on a healthcare product with neural networks. We're calling it OBER. It's a mental health product, but it's going to change the landscape of how emotional wellness is going to be perceived. Um, we are using cognitive behavior therapy. We are using dialectal behavior therapies, and we are also using adaptive behavior therapy and sort of neural networks to associate with that. We're building a product along that sidelines. I just wanted to bring it up. It's going to take some time for us to sort of talk about it in detail. Um, hope to gain success in that. Thank you so much. Thanks for your time. I'll open for
Okay.
questions maybe after the session. I'll.
If you have any questions, you can go ahead.
Yep.
Some data set for
Yes.
it to train, right?
Yes.
So where do you get this data set from? I mean, are the hospitals willing to share
Yes, you
the
need to
data?
partner with them. Like Rajesh was mentioning, there's a lot of regulatory process as well. In India, it might not be as serious as how it is outside. There's a lot of HIPAA compliance that you need to follow. There's personal information that you need to mask and sort of. There's a lot of things that change when the geography changes, right? So how you predict a disease in Africa versus how you predict a disease in India would be different, right? Because of environmental conditions, that the fundus, the cohort changes based on geography, based on the type of network that you use. So it is very important to sort of categorize your data, very important to get the right information in a time series way so that it can understand how things have changed in the past as well.
So are new companies able to get that kind of partnership or such data? I don't know how big you guys are. I'm sorry for that, but
No, it's difficult. It's not as easy as possible. You'll need to have a partnership with someone who's a giant in the space. Uh, Maybe you can work with data models that already exist as open source, which have some data that already are fed in.
right.
You can use those data models to sort of help your tool or application that you build to get them better. But if you want to build something from scratch with your own data, it's going to take some time and effort.
Thank you.
Thanks. Okay, thanks a lot.
One more. Uh,
Yeah.
so, how do you maintain the regulatory compliance in the results generated by the neural network or ML
So
products?
I can't hear you.
Is it better?
Yeah, it's better now.
Yeah. So, how do you maintain the regulatory compliance like AMA and like whatever results generated by ML or deep learning models? How do you maintain that?
So what do we store? We don't store information of patients. We don't store what the neural network keeps with itself is nothing that is with respect to any patient or anything, right? So like I said, that has to be very clear from the start, right? We sort of convert it into tokens, vectors, and when you move it to NLPs and large language models, you sort of move it into a vector-based data storage, tokens, and so on, which sort of help you store it in a better way. But regulatory aspects come into a large portion here, and it has to be very critically looked into. Okay, thanks a lot.
We have.
One,
Sorry. Yeah. Data quality, good question. Data quality is a challenge, right? So, like in one case study, you have certified doctors who are looking at it, labeling it, and pushing it across. Right now, in today's world, you sort of, at least as techies, we sort of depend upon the quality of data that is available, right? Probably eventually, when it uh, back propagates and tries to learn, it can get better, but there's no clear answer to say that, okay, I have this fundus images or I have this cohort of data, this data set, which is absolutely clear and correct.
Yeah. So when you say my accuracy is 95%, that means that 5% is because the data quality is not well.
Correct.
So during the time of annotation and all those things, right? So do you have some domain expert who makes sure that whatever the data you are basically gathering from your partners, right? So are those data sets, right? So qualified to get into the model. So do you have all those, data quality process, etc.?
No, I'm going to be very honest. We don't have that right now. We are pretty much at the early stage trying to understand how things work and with existing models and existing data sets that we have. But great question. We can talk about it when we find time. Thank you.
Perfect. Thank you so much.
Hi. Is my voice clear?
Yeah, sure.
Hey, thanks for the session. You made very complex things very simplified. I really liked it. But I noticed that you had not talked about LLMs, which is very popular in all the discussions.
Well,
right?
Pramada, sorry for saying this. I initially had a 10-minute slot, and then I had a 20-minute slot, and I covered what I could in this time because I did not want to get into a lot of other aspects. I specifically focused on two specific things that we were actually working on in WebNot.
Okay. I mean, does that mean that you're not looking at LLMs as possible?
No, we are looking into it, but not as specific as or detailed as these couple of networks. Thank you. Thank you so much.
Thank you.
Hi, I'm Satish. I'm interested in the applications of IT technology. My question is, when I saw the map of experts, the North America was all green, and I'm sure most of them are Indians or Chinese over there. So India was orange. So I don't know what that means. How far behind are we, and why are we lagging behind? Because we are exporting.
So we are in short of experts who can, we do have radiologists who sit in a laboratory, next door and sort of understand and try to read reports and sort of come up with what is an issue and what could cause cancer or something, right? But we are looking at experts who can, sort of predict what can happen to patient, right? So you see, in one of the images for retinopathy, so it depends on the hemorrhages in the image, right? For example, the amount of blood spots, the size of blood spots that are on the image, right? We don't have experts who can analyze and have the experience to say, okay, you got to do this in order to avoid a diabetic retinopathy, right? So these are problems that we are facing, and even Shankara hospitals and Arvind hospitals, they are in short of, like I said, there are 127,000 eye doctors that are short of in India, right? Like you said, probably people have moved on to the North America region or the other places. That's why it's green. But we are definitely short of specialists who can, sort of make the world better. Because if I go to a radiologist today, he probably looks at the report and he says, okay, maybe you might be prone to cancer, but I don't know if there's something else that the report says that this person does not know to read out.
So the problem lies in the colleges. We need medical technologists who has both medical knowledge as well as the applications of the technology.
The problem lies with, in my opinion, I'm not an expert in that area, sir. In my opinion, it lies in the quality of doctors that reside in India.
So can that be, I'm not an expert either, but can we have specialized courses just like radiologists and train maybe people in your field who are already at that level can approach colleges and medical colleges or even engineering colleges and say, why don't you bridge that gap? And because this, I feel, is going to be a big...
Definitely.
Because India is going forward trying to become the third biggest economy in the world. So people like you can probably spend some time, your spare time, and initiate that. The second question is there any application on symptom diagnosis? So
yes,
that would be the next biggest thing apart from the radiology. So people can self-analyze, if that's a dangerous word, but and also what is the application in natural medicine? Because I'm sure because India is leading in natural medicine.
Okay.
So the focus is mostly on Western medicine, which has proven to be very backward in terms of achieving any results. So is there any push towards analyzing natural data, use naturopathic uh, database that we have, traditional database, Chinese medicine, Indian medicine, and things like that? Is there any interest or any?
So there's drug discovery that's happening. Yes, there's a lot of money that's spent on drug discovery as a science itself, and because it comes a lot from the West, there's a lot into the Western drug, English medicine to be specific in layman words. It's a good point that we'll have to start looking into areas of homeopathy, Ayurvedic, and natural treatment that comes from the root of us. That's a good point. I'll take that as a feedback.
Yeah,
We'll work with
one
our community.
being with yoga, I could say if you have specific back problem, so the software makes a diagnosis of you have sciatica, and then these are the yoga poses you could automatically do, provided you don't have any other symptoms. These are very simple applications, but that we always have to bring it to the grassroots level because we
Correct.
shouldn't keep it in the hospitals and colleges and research departments. So this is even with robotics. So we always talk about bringing it to the grassroots level. Thank you.
Thank you so much. Thank you. Okay. Yeah, sure.
So, hi, sir. So basically, the thing that you are saying on natural medicine. So actually, I'm also a founder of Marty Farms. So we are doing this for animals. Actually, we have been collaborated with GV Pant University of Uttarakhand. If anyone has been interested, so we have been working on that. And coming back to the we've been doing that work for humans also for natural medicines and other stuffs. We figured some issues with FSSI also. Like whenever you try to recommend some natural medicines, you have to first get certified with FSSI, and unfortunately there is a lot of corruption in India, so we were not able to proceed. Even I thought to come here just to have interaction with the existing people. So yeah, we have been working for animals because the laws are a bit soft with them. So probably yeah, if we are connected and if I'm alive, we'll probably work. Yeah, in agriculture, actually, we've been figuring this problem that in especially in animals, we do find a lot of medicines are bit costlier in animals. If anyone have pets like dogs and other stuff, they do know. So we are working on that for animals. Yeah, thank you.
Thank you so much. Thank you, Kousick. Please give him a round of applause. Great. Thank you, everybody. Before we head into the break, we have one tiny small thing to do. We have to give away speaker gift boxes to our speakers, first two speakers. So Kousick and Rajesh, can you please come up here, and also Pramada.
Can we black out the lights? I'm super excited to announce the GeekConf happening next year in collaboration with obviously the great organizers of React India, JSConf India, the company that I run, GeekyAnts. The theme is going to be around open source and full stack, obviously.
So all set. How's the snacks? I hope you have enjoyed it. Okay, really good, nice one. Still, if you want to grab some chips, you can please. But yes, I just want to mention one thing. I must do that because I feel that number of hosting I did, but I feel in number of events, they used to just put the videos, they used to take the pictures, but this time I feel nothing was there. Why? And I feel really amazing because you were listening, and that's really commendable, and cheers to all. So without further ado, I just want to mention right now, let's move to the next speaker. His name is Siddharth Ajith. He is the AI Technical Product Manager at G Healthcare. He has over 13 plus years of experience overall, and today he is sharing his knowledge on what is the role of AI in personalizing healthcare. Let's greet him warmly. Put your hands together.
Hello, everyone. Can you hear me? Yeah, you guys are a very intelligent crowd, I could tell. So I will keep my sessions short and we'll keep more time for questions, if that makes sense. Okay. So yeah, I'm Siddharth. I work at GE Healthcare. I'll tell you about what I do. So I swear I was looking for this T-shirt today, okay, because the GeekyAnts folks hadn't met me. So I thought, okay, I need to wear this so that they let me in. Thankfully, they let me in with this T-shirt too. So it was out drying in the balcony, so I couldn't wear that. But yeah, quickly about me. So I've worked at GE Healthcare. I guess all of you would be familiar. It's an $18 billion revenue company. We touch about 1 billion patients, billion with a B, patients every day with our devices, applications. So these devices are across the entire product range, starts with like imaging, goes into monitoring, anesthesia, respiratory care. You enter a hospital, any device you see is probably, we make it, not that it's made everywhere by us, but yeah, we make it, so that's what GE does. About me, so I work as an AI product manager. Actually, before that, quick survey, okay? So how many of you here are data scientists? Show of hands. Okay, not bad. Any clinicians here? Doctors? Okay, you're a doctor? Okay, what area? Neuro anesthesia. And how about you, sir? Okay, okay. You're not a practicing doctor, but okay. That's great, okay. Product managers? Okay, nice. The rest are engineers, I'm guessing? Can you raise your hand, engineers? Okay. Any other, role I've missed out on? Okay. Okay. You can see that I'm an engineer too. We're all engineers. So, businessman, wow. He's the most important person in the room, by the way. Huh? He's got the most money. So, any other role I missed out? Okay. You're in consulting. Okay, nice, interesting. Huh? Okay, another thing I wanted to ask you is how many of you work in healthcare? Almost everyone. How many of you work in medical devices? Anybody medical devices? That's nice, not bad, huh? Health apps, therapeutics, digital therapeutics. Not bad, okay. So collectively, this crowd knows a lot more than I do. I can say that for sure, okay? So, yeah. So what do? I work as an AI product manager. So AI product management is a little different from software product management. So we work alongside data scientists mostly, and of course with engineers to deploy the applications we build, right? And there is of course a difference in what we develop, and I'll tell you more about applications that we work on. We are in this domain called precision care, which is applications that are used by clinicians at the end of the day in a hospital setting or in a primary care center, right? So which means we undergo regulatory scrutiny. So it's not that we can develop something and just deploy it. We undergo very strict regulatory scrutiny. And also the disclaimer I've given at the bottom, right? So my exposure is primarily to the US market. So a lot of what I say here will be relevant to the US market, but by extension, you could say it is true or will be true in the Indian market. So yeah, that's me. Okay, I'll keep this a little interactive, okay? So we have a doctor here. I don't want to ask him, he will know the answer, but anybody here on what is a clinical versus non-clinical algorithm, let's say? Anybody? Any guesses? What's a clinical algorithm? What's a non-clinical algorithm? Or should we go to the expert straight? Yeah, go ahead. Yeah, very close. Yeah, very close, very close, very close. Yeah, you're almost there. Anything else anybody wants to add? It's actually mentioned here, but yeah, I still. yeah.
Anything related which is impacting the health of human beings, that's clinical?
Practo will say they impact patients' health also. Is that a clinical app?
No.
It does, by the way. You're right, but Yeah, so I think it's here, but I would say simple, right? So anything that a physician or a nurse or any clinician uses at the end of the day to take a decision falls into clinical. That's the simplest way to put it. So anything that a physician uses to take a decision or or a nurse uses to take a decision falls into clinical use, right? And that's where I think a lot of difference in terms of how we develop an AI algorithm comes into play. And we'll talk about the patient journey briefly. It becomes a very different domain, very different territory. It requires intense research, intense development effort, intense testing, regulatory clearance, takes months, sometimes years. And after that, you go into the field. You can't do federated learning. You can't retrain your algorithm when you want to. It's another release. So there is all of that, right? So when you talk of AI product management, it's all of that. You start with development till deployment, retraining. Then do you want to do another release? What's the life cycle? You plan for the life cycle, get it out if it's not required. So all of that, right? And which is where I think a lot of clinical use case algorithms don't even make it to the market because there's so many hoops to cross that we don't even make it to the market eventually a lot of times. So that's, I think, the big difference. And I think the way we approach development also kind of changes, right? So yeah. Okay, so I just want to quickly touch upon what a patient's journey is like, right? So it's kind of shown here. And before I jump into this, I quickly had a question for you, okay? And this is the data I came across recently. Any guesses on what percentage of data generated across the globe, okay, all data, is healthcare data? So this includes everything, okay, social media data, I don't know, like there are like vehicles on the road, that data is captured, there's spacecrafts, there's all the data we generate every day. What percentage of that is healthcare data? Any guesses? 5%? 30%, you know it. It's 30%. 30% of all data generated is healthcare data. And I was a little baffled when I heard it for the first time, but then if you dig deeper, you realize it is true. All the data generated and captured, 30% of it is all the data that comes from our body essentially, in different forms. And we'll talk about how that data is captured, not captured, structured, not structured, all of that. But that's the volume of data we're dealing with, right? And the reason I mentioned that is if you look at the patient journey, nowadays what happens, and again, this is a little bit more of a US context, but this is true in India now too, is that you look at the various stages or, let's say steps through which a patient goes through to finally get care, right? It's important to understand this journey because there are many touch points on each of these steps. And understanding these touch points, understanding the data that is captured, understanding how that data can be used, is there a clinical use for it? Is there a non-clinical use for it? I think that becomes very important, especially for, let's say, anybody, like even for a data scientist working in this domain, right? Just knowing data science will not take you too far because you'll have to understand what the context of that data is. And even for product managers, you'll have to understand why that data is important, how that can be put to use. How do we kind of even just store that data? We don't know, we may not use it today, we may use it 5 years later. Can we even track that data, right? So I don't want to go through this as right in front of you, but I'll talk a lot about stages 3 and beyond, right? So the first is, of course, there's a trigger. Let's say you take any condition, right? So let's say you have a pain in your chest. That's a trigger. You take an appointment. HCP is a healthcare provider, right? So this could be a hospital, this could be a primary care center, this could be your family doctor, or not a family doctor will probably refer you to an HCP. So you go there. Stage 3 onwards is where actually your physician or or any clinician gets involved, right? And that is where I think as practitioners in this field, we need to understand how patient data will be used. We need to start at stage 1 also, and there's a lot of great products coming out in that space. Your wearables are a good example. You're tracking data all the time. It's capturing a lot of data, and it will evolve. It will come up. But I think as practitioners, we need to understand how the data for stage 3 and beyond will be used. I was talking to somebody today, and he works in stage 6, which is ongoing care, right? You work in stage 6, right? Which is and it's for cancer patients who are recovering. So that is again important. I mean, each of these steps is important, don't get me wrong. But I think a lot of work today is still pending, even in stage 2, 3, and 4, right? Where the physician or the nurse needs inputs from the patient data to say that, okay, this is the action that needs to be taken. Can we give predictive information on what needs to be done with the patient? So yeah, quickly I wanted to show you this. And yeah, again, 3 big challenges. I mean, there are a bunch of challenges. My earlier speakers have covered a lot of those challenges and all very relevant. But in my experience, I feel like these are the big 3 challenges, especially in the US context, right? So maybe not so much in the India context, but this may happen soon. The first one is clinician shortage. There was a survey in the US recently where 50% of nurses said that if they get a job with an equal pay elsewhere, they're willing to leave their job, right? 50%. They're overworked. They're more than 50% of their time goes into doing documentation, mundane work, routine work. And the last thing you want to do is to introduce an application without understanding the clinical workflow and getting them to do more work. It's like I replace if you're on iPhone, I give you an Android right now. It'll easily take you a few days to adjust. I mean, we're all still young and maybe we have time, but clinicians don't have time, right? The last thing they have is time. So that's a big challenge. And I think a lot of applications, products, solutions are really trying to address how we can kind of take care of that shortage. Second one is extensive data. I was just chatting earlier. There is data, there is patient data available. It's not structured, it's not accessible. There are no common protocols for a lot of things. There are there is the HL7 protocol and things like that for devices, but we don't have common protocols for storing data. So yeah, you were just giving the example earlier that, I went for an appointment to an Apollo hospital, for example. Now, can I go to another hospital and will that data be available to that doctor? We don't have those systems in place yet. In the US, they still have EMRs which can share data across hospitals. We have EMRs in India too, and to be honest, I'm not aware how good those are. Maybe those are very good, and some of our friends here can, they work in this domain, they will know. But I think getting extensive data, exhaustive data is a challenge, right? And again, I go back to the chest pain example. Can a doctor today know what the history of this patient has been, even if it's basic data from your Apple Watch, right? Can you get that data? Today, that's not available. Making that available itself is a big challenge. And third one is kind of related to the second one. How do you manage ongoing basis kind of manage a patient, right? So data is one part of it, but also how do you ensure that there is continuity in care? And that is another challenge. So you might intervene at one point. Let's say today we are all coming up with point solutions, right? So there's an app, for example, at stage 6, where somebody is done with, let's say surgery, they've come out, they've gone home to take care of their recovery after that. There might be another set of solutions before that. Is there a continuity in these? Not today, but that's another big challenge that you'll have to think of. Now, again, so this is something I've kind of seen in my experience at GE. There are 2 big trends, right? 2 big shifts happening as a result of AI and data coming in. And not just because of that, I think in general, human nature, the pandemic played a role in it also. There's 2 big changes happening at this point, right? So here on the x-axis is how personalized your care is. And on the y-axis is intervention, which is, and I'll tell you what acute care is and preventive care is. Acute, yeah, so, let me just actually show you that. So right now, let's say we are here, right? So we are providing standard care for most conditions, treatments, and it's acute. Acute meaning you need to go to a certain healthcare provider, you need to go to a hospital, you need to visit a doctor to get that care. From there we are moving to precision care and being preventive, right? So precision would be, of course, highly personalized to what your condition is, what your history has been like, and being preventive in nature, which means that we ensure that we catch the condition before it even evolves and becomes big. So that's one big shift that is happening, and most, not just device companies, healthcare companies are kind of aware of this, cognizant of this, they're moving in this direction. And the other big shift is location and visits, right? So on the x-axis, you have the physical location of where the intervention is happening. Today, it is happening primarily at primary care centers or hospitals, right? PCC here is primary care center. and the number of visits is high. We are moving in this direction, and here the pandemic had a role to play because you didn't have a choice. You had to seek whatever help you wanted at home, and for a lot of things, not for everything, of course. But what will happen in time, and as device companies, we also think about how many of these devices are getting miniaturized. I don't think anybody even knew what a pulse oximeter is. That what it's called? Nobody knew what that was before the pandemic. Today, probably everyone has one at home, or you have it in your wearable, right? That's an example of how many miniaturized devices will start showing up either as part of your wearable or separately. And especially, let's say now with my parents' generation, for example, right? I remember like my grandfather, he's no more now. He had to go to a primary care center every time to get his BP checked. This was maybe 25, 30 years back. Today, my parents don't have to do that. And my mom is diabetic. She doesn't need to go anywhere to get her blood checked, blood sugar level checked, right? She does it at home. She has a device for it. That's the direction in which we are moving, where a lot of monitoring, a lot of prevention will happen at home. There will be miniaturized apps, devices, all of that will play a role. And which of course means that the number of visits that you make to a healthcare provider, to a doctor, primary care center, that's going to go down. So these are the two big shifts that I think most players in this field are cognizant of and they're working towards. Okay, so like I mentioned, these are the four things that are happening, right? So from the previous trends. Now, what does personalized care mean? It means you need to have detailed patient data and history, right? So that's the implication from this. If it's preventive, it means that we need to have detailed study of conditions, research on. So for example, can we catch, I don't want to take the example of cancer, but any other condition, right? Can we catch a heart condition before it even happens? Can we detect it, let's say, 1 year in advance, 6 months in advance, or even 2 months in advance, right? That itself is something that would be an achievement. So that would be a step in the direction of being preventive as opposed to being reactive. Home focused, of course, I mentioned. We need smaller devices, more efficient apps, more efficient information. I was earlier kind of taking a dig at Practo, but actually they're providing this, right? So that you don't need to go out for smaller things. You can actually just consult the right an expert right at your home and get the information you need. You don't need to be anxious about what's happening and wait for your turn, go and meet a doctor. So you can do that sitting at home today. So that is again something that will happen and is already happening. Yeah, monitoring is again, like I mentioned, we have limited monitoring today. Just out of curiosity, how many of you have a wearable device, smartwatch? And out of you, how many of you regularly track your heart rates and different stuff, different healthcare data? Not bad. How many of you work out? At least 3 days in a week? Not bad. This is a very physically active crowd. Okay, so that's good. Now, all of this would mean, right? It means a lot of data. And I was talking about 30% earlier. Now, this 30%, my data science friends here will tell you is junk unless it's stored properly and it's not structured. And it's not structured. I can tell you that for sure. Even the most structured data sets are not structured. So you can imagine what happens with, so quick, okay, again, to the data scientists, okay? What percentage of your time do you spend on data engineering, just getting the data set right? 70, 90. Any other 70, 90? It's not less than 50, I'm guessing, right? Yeah, so your problem is as much as that of the clinicians. They spend 50% of the time doing documentation. You spend more than 50% of the time structuring the data. So you know now where the gap is, right? This data is good, but this data has to be structured. And another thing I was briefly discussing with somebody in the break is we are now coming up with protocols. We don't even have common protocols for data, for devices. Devices we do actually, but let's say in countries where it's not, there's no protocol or there are devices that are ad hoc in nature. You might get your ECG from one device and then I don't know if that data can actually be transferred to another EMR in another hospital. So that is again something that is being figured out. A lot of it has been figured out in some of the advanced economies and countries. I'm not sure how the situation is in India, but that's something that will have to happen for AI to even happen, right? Then comes the intelligence. After you do all this, after our data science friends sit and structure the data, we start with looking at if there's some intelligence possible in that, right? So can you draw some trends out, what you can do, what are some of the techniques you can use, etc. And then come up with insights. Finally, after all this, you come up with insights that you can share with either the clinician or with the hospital, depending on the use case, or with the patient. So I think if I have to summarize what the data and AI challenge in healthcare is, it is this. We have data, the data needs to be structured, then you add intelligence to it, and then you come up with insights. So I think the base of the pyramid here itself needs to, first we need to get the data, and then after that, the second level, right? So that's the bigger challenge at this point in time. Yeah, I've just shown some use cases here. I just wanted to give some examples of, what all happens with some of the data that you can use. But again, doing all of this, doing drug discovery requires you to have that kind of a data set. And we can take some, one of the earlier speakers was answering a question on getting data from hospitals, right? I can give a 2-hour talk on that. It is a big challenge. Getting, especially with US hospitals, it's a big challenge because compliance is one part of the story. Getting agreements is another part of the story. And these are long drawn out processes. Thankfully, I work for a large company which has the resources for this. Smaller companies, startups really struggle. In the US, I'm talking about. In India, it might be a little easier. And that makes it tougher, right? So as an entrepreneur, if you want to develop something, I think it's really tough to just get your hands on real data. So my suggestion would be start off with existing data sets that you find on the internet, prove a concept, then go and try to get data, as opposed to waiting for the data to come, because that might even never happen. So yeah. I wanted to end with this quote. I love this book. I love this quote. And I'll read it out for you. So it says, the promise of AI in medicine is to provide composite panoramic views of individuals' medical data, to improve decision making, to avoid errors such as misdiagnosis and unnecessary procedures, to help in the ordering and interpretation of appropriate tests, and to recommend treatment. If I have to summarize what AI can do in healthcare, or what AI should do in healthcare, this is it. How do we get here? Yeah, let's all sit and brainstorm. It's not an easy problem. It's not an easy challenge to solve. But again, there are a lot of companies, large companies, small companies, startups, taking up smaller use cases, trying to solve those. Because solving the big piece is always challenging. It's better to take smaller point solutions, start with that, and see how you can take it forward, right? So, yep, I'm at the end of what I had to say. Happy to take any questions if you have any. So yeah, over to you.
Hello. I'm Satish. I had a question for big companies like the one you work for. Their focus is mainly on hospitals and the organized sector. So at what point, or is there any plan to get to the grassroots level? Like you talked about wearables, and that's a whole wide open field. Like even to simple a counter, a timer, I can't get one right now. I don't have to spend 50,000 to get a small timer that will just give me a beep to control my breathing, because I'm a yoga teacher. I teach pranayam. So there's nothing that I can go and buy for 100, 200 rupees off the market and say, okay, use this. Stopwatches don't work so well. So you know where I'm going with this. So simple things like I can talk about 10 or 20 devices that you can develop just off the shelf. So is G focusing on that field, or are they just going to go where the big bucks are? Because there are big bucks here as well. Because if you sell something for 200 rupees for 500 million people, that's a lot of money. So why isn't the big pharma, I would put GE in that big pharma category, because they are tied to the hip with the big pharma. Why are they not focusing on helping the common man? Is there any mandate that no, don't look at the common man? We need their money, their tax money, but we won't do anything for them. What's going on there? Maybe you can give some insights.
Yeah, sure. I'm going to forward your request to our CEO, by the way. But so just a clarification, we are not a pharma company. We are a medical device company,
Yeah, and so-
right? So please have a seat, sir. Please have a seat. Yeah. So, so two parts to that. One is at least the devices we make, our customer is the hospital, the physician, let me say. The user of the device is a clinician, physician, nurse, and we are focused on what I was mentioning earlier, which is called acute care. Acute care is, let's say there is a certain condition that develops, something of that nature. You visit a doctor, hospital, and we kind of provide devices for that. The second part of it, within that, I mean, I don't work in that domain within GE, but I know for a fact that GE has developed a lot of affordable devices within this domain, right? So a lot of affordable ECG devices. There are now, so there is this product called Alive Core. You can check it out. You don't need a full-fledged ECG machine to quickly check somebody's ECG condition. It's a small variable you put on your heart and you get immediate results. Low cost one as well. So I think a lot of our innovation is focused on the devices we have, on the applications we have, and we're trying to see how to make that affordable. On the other hand, I am also aware that a lot of large companies, including GE, have programs where they work with startups working on this. So I was just talking to a friend from Cure AI. Cure AI is one of the companies I believe that is part of GE's accelerator program, where we work with companies that are working in this. So they develop solutions, they develop products that actually are solving much more point problems for a local market maybe, and that's how I think GE approaches it. I don't know why GE doesn't want to get into it. That's above my pay grade. But my best guess is that, look, GE's biggest market is the US and Europe. And a lot of the devices that GE makes and sells, I think the I would say the target audience for it, there's like a lot of things in it. So we have a doctor, he'll tell you there's something called a clinical workflow. You need certain resources to have those devices. There's a certain system you need to have to store that data. So given all that, I think the company has prioritized selling to hospitals. So yeah, that's the best answer I can give you. The rest I'll forward your request to our CEO.
Yeah, if you have any experience about certifying an algorithm, clinical algorithm, what kind of things should be taken care of in the
You mean
context of-
regulatory clearance, right?
Yeah, so suppose I have an AI algorithm which can be used in a clinical application, let's say detecting arrhythmia, okay, using probably the latest AI tech like LLM or something like that.
LLM. Okay, so LLM is a different question. We'll come to that. But yeah, before
I
that,
mean,
this
I
one.
just give an example.
Yeah.
So what sort of certification would be needed to qualify that algorithm for clinical use? If you have some idea.
Got it. Yeah. So I'll just rephrase the question. I'll say to go to market, you'll have to get regulatory clearance. So at least the FDA, any AI algorithm that is for clinical use has to be cleared by the FDA, right? There are various steps. You will get details on the FDA's website also. But I can quickly tell you that you have to, of course, develop the algorithm. There are certain requirements in terms of what kind of data you need to use. There is a certain diversity prescription. Not prescription, but there is a requirement. You need to prove that your data set is large enough. It covers different aspects. It depends on what the use case is. So let's say, for example, if you're looking at, I don't know, you said heart condition, right? So you'll have to look at, for example, ethnicity. Are you covering all ethnicities? There are certain ethnicities that tend to have higher heart condition rate. I believe India falls into that, right? So you'll have to prove how your algorithm doesn't have bias. There are ethical concerns that you'll have to take into consideration. You'll have to prove that there is no regression in your algorithm over a period of time. You will have to deploy it, get clinical validation, which means that you deploy it either in the field or retrospectively, get feedback from clinicians, and they have to certify it and say that, yeah, this works. Then you present all those results and make a submission. It takes 6 to 9 months for the FDA to come back to you. They will come back to you and say, okay, this is good to go or not good to go. So it's a long drawn out process. So I've been through it. A couple of other speakers have been through it, so it's a lengthy process. If are you a startup, sir, by any chance? You're a startup. You're trying to do this. Okay. Have you, which market are you looking at? The US? Indian market. Okay. I'm not the expert on Indian market, I must admit. He'll be able to help you. Yeah. Yeah, he's right. I was going to say that. So there's a regulatory team that takes care of this, and they are aware of these requirements. So as a startup, I would say see what you want to achieve and then decide where you want to get regulatory clearance. So yeah. Yeah.
Thanks for your session. So you stated that out of the challenges, the 4 challenges that you have shown, the unstructured data, it looks like it's a challenge both for the maintainers, clinicians, as well as the consumers, data scientists.
Yes.
And
Yes.
it will unblock the next levels.
Yes.
So, and you also mentioned about some protocoling.
Yes.
And is there a consortium which works on it to set something? You can share
Yes.
something.
So for devices, yes. For devices, there is something called an HL5, HL7 protocol that they're supposed to follow. And you can Google it, you will get all the information. Now, these are prescriptions. These are not directives. So which means that, you know, this is prescribed, but you can choose to not do it also. It's not that if you don't have, you will not be allowed to sell in the market. However, most large medtech companies follow these protocols because they want interoperability. They want, for example, a device made by GE to talk to an application made by some other company, or vice versa, right? Or device made by some other company to talk to an application made by GE. So for devices, the answer is yes. For EMR data, I'm not sure. EMR is electronic medical records, right? So EMR data, I'm not sure what is the case. Yeah. Yeah.
So I have this question. So like you from a product manager perspective, how do you know how do you gauge the business profitability for such things, because that also plays a big role into what goes into the market. Like
Yeah.
you can have a lot of use cases to solve, there are plenty of use cases, but again it becomes what a business call is for a for a profitability purpose.
Yeah.
So how does you know, like how does all of your product and what you make on a day-to-day basis drive those decisions for you?
Yeah, it's a great question. I would say it's a little different from, like, for example, before I joined GE, I was an entrepreneur. I had a SaaS product, right? So there it's very easy. How many users do you have? What is the usage? What is the, you know, different rates? You have calculate all of that, and those are your success metrics. With the devices and applications, a little different. It's very much more long term. You know, you look at 2-year, 3-year horizons. You rely a lot more on feedback, surveys, things like that to understand what the acceptability of this will be. At the end of the day, you have to sell it at a premium. That's the only way to do it. You know, you are an AI enabled product and you sell your product at a premium. So from a revenue standpoint, that's what you look at. Success metrics, I think there are multiple things, right? So the biggest one for us is clinical success metrics. So what is the feedback we're getting from our users, which is physicians, nurses, whoever is using it, based on the type of device. So that is the biggest, let's say, month on month kind of a metric for us, because we collect feedback on the kind of output we are giving, right? So that's the ultimate one for us. Then of course there are other metrics, like let's say so the user is of course the physician, but the customer is the hospital. So then we get feedback from the hospital. We also have the patient. Patient is the center of everything, right? So if there is, let's say, patient feedback required, we look at that too. So those are some of the metrics we look at, ideally should look at, to gauge success of, you know, AI algorithms and with clinical use cases. Yeah.
Because also there is some scalability issues, right? Like I mean, let's say there's some great idea, but then that idea will not come forward because it is probably servicing a very small problem out of all the pictures, and those could be a great breakthrough in general, but it may not be applicable as such in a lot of fields. So then how like a person who's wanting to you know, do something better in these aspects in healthcare, uh, come out of these challenges, or is there something they can deal with on these?
It's not very different from, let's say, so I was enterprise SaaS. It was not very different from that to this, if you ask me. So here you treat a hospital as an enterprise, let's say, right? It wouldn't be very different. You go to a hospital, you have market, like in large companies have market research teams. So they go and do research and understand what is it that customers want, hospitals want. Then there are clinical teams we have also. They go and reach out to, other clinicians and understand this is actually a problem. So there is, I think, a lot of data we need to collect from all these places through market research, through customer interviews, interactions, surveys, at the initial stages. Then, of course, time to time, you need to be quick in deploying what you're doing. Not deploy as in like after getting clearance, but initially at a POC stage, testing it out and things like that. So there are ways to, it's a long drawn out process, but there are ways to cut short the feedback cycle that we have.
Thank you. Just one more question. Sorry. So you mentioned about you cannot retrain data once you go into the thing. I just wanted to understand more on that.
Yeah. So as per FDA at least, and again, please take this with a pinch of salt. This might be different for different markets. But for the US, for example, you're not allowed to retrain an AI model once it's deployed. So federated learning is out of the question, for example, right? You have to go through a clearance again if you're using a new data set, for example, or you're adding to the data set. You have to go through a kind of clearance cycle again. So that's a limitation you have to live with. And the reason is, of course, it affects the patient's life at the end of the day. So they want to be very sure, and I guess it's right. Yeah.
Hi. Here.
Oh, okay. Hi.
Hey, my question is on the compliance and about FDA and HIPAA. So if there is data coming out of an EMR, and if that is progress note, clinical notes and all, clinical note data coming out, and that is not owned, but that is for a provider in the US market, right? And if the provider is or if somebody from that company which has deployed the EMR is developing an AI app, and that is mostly about the billing, claiming RCM, something related
billing,
to RCM,
okay,
right?
okay.
So, but even then, it has this clinical notes inside it.
Yes.
Right. Now, does it still need to go through FDA and HIPAA and all?
HIPAA for sure. So
HIPAA
anything that has a patient identifier so there is a compliance, HIPAA compliance that you do for any patient data. FDA not necessary. So if it's not for clinical use, so let's say simple, right? Somebody mentioned LLMs. Let's say come up with some kind of an algorithm to summarize patient reports. My best guess is that doesn't have to go through FDA, because that is not for clinical use, right? There is no decision being made.
Okay, so when there is a decision which impacts the patient, only then the FDA comes in.
Yes, and patient data is the input. Patient's history, patient data is the input.
Yes, that is an input for the billing part, but it doesn't impact the patient. It impacts
the patient directly. So those don't need to go through the FDA.
Okay.
Yeah. So I think the simplest way to look at it is, if a clinician is going to look at the output of an AI algorithm and going to take a clinical decision on the basis of that, then that has to go through. If it is part of the clinical workflow, then it has to go through the FDA clearance.
Okay.
If not, then not really. But yeah, thank you. Okay, cool. I think we're out of time, but we'll be happy to connect. My name is Siddharth Ajith. I'm on LinkedIn. So let me go back to my name. Yeah, that's Siddharth Ajith is my full name. You'll find me on LinkedIn. There's not too many Siddharth Ajiths. So happy to connect, and please reach out to me on LinkedIn. We'll be happy to speak. Yeah. Okay. Thank you. Thanks, everyone.
Thank you so much, Siddharth, for your invaluable expertise on the key trends of AI healthcare. Have a huge round of applause again. So, ready for the next speaker? Yeah. So, we want to introduce our next speaker now. We have Shyam Kumar. He is the senior data scientist at Carelon. His talk is going to revolve around applications and risk in AI in healthcare. Join me in welcoming Shyam.
Good evening, everyone. One sec. Good evening. Nice. Good evening, everyone. I'm Shyam Sunder Kumar. I have been building AI products for past 4 years, and for past 6 months, I have been working with large language models. So my talk will revolve around large language models and applications of large language models. So starting on that note, these are the things that I will cover. Healthcare challenges, then we will dive a little bit into large language models. Then we will look into biomedical LLMs, application, and some related risks. So these are some key challenges in healthcare. First is rising cost. Healthcare cost, every year it rises very much. Medical error is one of the main healthcare challenges. In one report in US, medical error was third leading cause of death. Data complexity and also workforce shortage. On another note, Google receives more than 1 billion health questions every day. So people are looking for answers, and at some point we have tried to search something on Google related to some health condition, and we know our experience, like what happens. Now jumping to pre-large language models era, what was happening is like we had multiple machine learning models to solve these multiple tasks. So for example, for clinical dialogue, we have summarization model, and then it summarizes this clinical dialogue. Now we have this entity recognition model, text classification model, and question answering model. So the main thing is like we have multiple machine learning models to solve these multiple tasks. So each task we are targeting with a different machine learning model. Now, why there is so much hype for generative AI? Why there is so much hype for generative AI? The thing is like we can solve these multiple problems using a single large language model. Now, based on our problem at hand, we can modify these large language models in such a way so that we can solve the problem using just a single language model. Now, this is very interesting, like how we can solve these different kind of problems using a single model. Now, let's look into this. So data is the new oil. So all these applications, these large language models are driven by data. These are driven by billions of data points. So just for an example, let's look at ChatGPT. How many of you have used ChatGPT? That's nice. So ChatGPT has been trained on a huge corpus of data. It has been trained on the whole of Wikipedia, the whole of C4, the whole of book corpus, and the whole of PubMed abstracts as well. So it has mix of data. We can see that there is web pages, conversation data, books and news, scientific data, and also code. So now moving to next slide. What happens once we train these language model is like we can give it a question and we can receive a response like this, like what is metformin, and then we get some response. Now one interesting thing is like once we modify this input in a certain way, we can also modify the output in a certain way. Now in upcoming slides, we will see how we can do that. Now it's okay. So some benefits of foundational models, I mean large language model is like we need less label data compared to when we build a single ML model for a task. The model deployment is simplified. We can also handle multiple data types. For example, we can handle image, we can handle protein types, we can handle many different kind of data. So not just chat gpt, the large language model ecosystem is really large. Every big companies are releasing these models. Some of the notable models we can see like Anthropic, GPT-4, chat gpt, and all that. Now moving to biomedical large language models. Now these large language models are generic kind of models which to some extent for some simpler tasks may work very good. But if you want to solve a really complex task, you will have to fine tune this model on medical data. So here we can see a lot of medical data. We use these data to fine tune these large language models. Now every big companies has released these big large language models like BioGPT, MedPalm 2, and we will see that how we can use these big large language models. Now a lot of people are experimenting with these models. So for example, PubMed BERT has a millions of download per month. So a lot of people are trying to try these models for multiple use cases based on their needs. So I want you to focus on one thing, that we have this millions of electronic health records. Using that, we have trained a medical foundational model, and we have all these different tasks. But one very interesting thing is human AI collaboration. So for example, while using ChatGPT, it's very simple to use. The UI and UX is very simple. You type a question, you get an answer. So we need an interface that is very simple for doctors, nurses, and day-to-day user as well. So once we have these medical foundational model, these can be used by every day-to-day user in natural language. So for example, just if you know English and some basics of that field, you will be able to get answer related to that field. This I have stolen from Stanford magazine. Uh, this issue, they have given this medicine AI boom, and they believe that these large language models will have a very strong effect on medicine. Now, on application side, we can divide this in 4 categories. One is clinical practice. It can be used in biomedical research, public health, and health administration as well. Now, AI in clinical practice, we can see that it can be used to automate image analysis like radiology, pathology. It can also be used to automate a lot of signal processing as well. Some of the few examples that is given here is like detecting lung cancer from CT scans. You know, you can assess cardiac health from electrocardiograms and all that. Now, second application is medical question answering. So, for example, if you have a question like how long does it take for newborn jaundice to go away, you can get an answer which is good enough, good starting point. Now, yeah. So August AI, this is a very good company. It's a company from Bangalore itself. What they did is like they topped the US medical licensing exam with 94.8%, which is better than OpenAI GPT-4. And what their interface is very simple. You get a WhatsApp chatbot where you can interact with this model. So the interface is very simple. Rather than going on Google, you can ask these large language model these questions. Now, although it may not be correct 100% of the time, but it's a good starting point. It is better than Google for sure. Now, moving to visual question answering. For example, you have a report. Now, based on that, now moving to initial slide, our question was simple, like what is metformin? Now, Now imagine that you have a really complex task at hand. You have a CT scan or a skin photograph. Now you want to categorize this skin or this CT scan. So here we can see that there is instructions given. So for example, rather than just asking the question, we are also giving instruction to this model that how you have to behave. So we are saying that you are a helpful radiology assistant, and we are also describing certain condition as well. One more thing we can notice is that we are also giving that what kind of patient it is. Now based on that patient and based on that one example, it will behave in that way. So one of the very interesting thing about LLM is like you can you can steer it in certain direction based on certain examples. If you have like 5 to 10 examples, you can steer it in a certain direction based on your needs. Now another application is drug discovery. A lot of people are trying to customize this chat GPT thing to discover drugs. Just 2 days back, AstraZeneca had a huge agreement for AI-driven cancer drug candidates. So a lot of funding is happening in this space, and they are using large language models underneath. This is another application is genetic discovery. So it has used large language model MedPalm 2 to identify the genes that causes, diabetes or cataracts in this example. So one of the interesting things that we can see a pattern here is like you can take these large models and modify these based on your needs or whatever application you want to make. Another example is precision medicine, where based on a patient or an individual, you can modify the treatment. On the health administration side, there is we can reduce clinical note documentation, transcription. There are chatbots. It can also help in medical education as well. So it's a really evolving field. So you can definitely summarize all these findings in a comparatively easier way. So one thing I want you to notice here is like it's not just for medical professional. Even if you are a day-to-day user, it is helpful for you. So on the medical professional side, it helps in clinical documentation. You can create discharge summary. You can generate clinical notes. And on the patient side, it will help you to analyze lab reports. It will help you to analyze your wearable data, mental health chatbot and all. So it is empowering both the medical professional as well as the patients. Generative AI healthcare landscape is huge. The funding is every day you will see news coming up like this company raised this much funding. So a lot of people are working in different subdomains of this problem, which is interesting. Now moving on to risk. So some of the key risks for this large language model is hallucination. Hallucination is a big problem for large language models because what happens is like these large language models fabricate things that may look real, but they are not real. So this is something that we asked to GPT-4, that we said that your tendency to hallucinate at times when writing a medical note is concerning. Do you think it is wise to use you for medical note taking? Where this large language model GPT-4 says that I do not think it is wise to use me for medical note taking without supervision. So one thing is very important. Although we are very much excited about the application, we must use these technologies under supervision. Another thing is patient harm due to AI errors. misuse of these medical AI tools, risk of bias in medical AI, lack of transparency. These models currently, when it comes up a text like this, are we able to explain like whether this text why it is coming like this, why it is not coming like that? Also, if some patient is harmed because of AI, who will be accountable? So there is a gap in AI accountability as well. So these are few real life examples. So there was a one chatbot for preventing eating disorder, and these chatbots sometimes behave in a different manner, not for what it is made for. Also, a very big and known company, United Health AI, it was found that a lot of elders were denied pension or care based on an AI. So these must be regulated, and this must be deployed under supervision. Definitely, one of the best thing about these is like with time this will get better, but that will take some time. Also, this is one interesting paper where they are exploring that uh, can this be used for biological misuse. So, for example, we are finding a gene to solve, I mean, like to cure a disease, but this can also find a gene that can cause a disease. So it's like a two-way sword. So yeah. So overall, it's very exciting. It is a very powerful tool, but it must be used with a subject matter expert. It must be used under supervision. Also, there are ethical consideration as well. These models should not be biased, and there must be mitigation strategies for potential risk and limitations. Thank you. Yeah.
Just a second, 1 second.
So, for example, COVID. Okay, when COVID was happening, uh, we were preparing for it on an ongoing basis. You know what happened that time? There was a lot of AI was used, but it didn't work. Now, one of the best thing that we can do is like processing. Currently, what is happening is a lot of these company are using these technologies where comparatively risk is less. So, for example, in documentation, there is no life and death situation. It may error may happen, but there is no life and death situation. So, if you want to analyze population in a huge number, these applications can be helpful. Yeah.
And one more question. So while we're talking about many different possibilities of using AI, according to your personal opinion, what are the biggest challenges in healthcare which India is facing? Just your personal opinion on that.
Uh, since I'm an AI scientist, so I have a overall perspective, outer perspective, but inside perspective, maybe some domain expert would be able to tell better. Yeah.
Okay.
Excuse me. Just want to add to that question, the public health application of AI, right? So if you look AI, right now, I mean, we are an organization, we work in tuberculosis. So it's a public health problem across the globe. So that there's a technology, there's a problem, and AI is addressing. So tuberculosis is becoming, when you take the government of India, there's a program exclusively running to eliminate tuberculosis. It's called NTEP, National Tuberculosis Elimination Program. So government has a public health program. So to run this program, they need to screen or identify tuberculosis cases. So early identification of anything, so tuberculosis, I'm quoting an example, will add value to the health system, to the public health, to the community. Same with COVID, anything. So that is how AI is going to make one big impact in the public health ecosystem. And also, just to add to that challenges question from my experience, it's adoption. I mean, it's very easy to have that thing, and we can tell someone to use it, but to them to behaviorally adopt it, adapt it, use it in their regular operations. That is something we have to give the time, and we have to understand that it's not, they are not someone who's badly waiting to use it. So if the model is good, so there's an adoption challenges which we are facing across the globe. That is there. That is where which we are trying to resolve. So more user friendliness, more the interface should be as smooth as it is. That is the way forward for all the AI applications. Just to adding to that. Thank you.
Thank you.
So, like we are closely looking at the companies. Like I am from GeekyAnts itself, and we are having the clients who are actually coming up to look to integrate the generative AI. So we have seen the pattern from the manual working culture to the digital transformation, and now they are looking out to integrate the generative AI, but it's still very confused, right? That from where they should start it. So, for example, if we take a very simple a diagnostic company like a path lab, Dr. Lal path lab. So, how you will like explain them that from where they need to start the integration of the generative AI, so that they have the clearly understanding of the legal obligations as well, and the risk what you have actually shown. So they are still very confused that from where they need to start the integration. So how you will show the process of the integration of the AI into their whole workflow?
Now, every company is solving multiple problems. What I would like to do is like I would like to take two problems that they are trying to solve, and what I will try to show is like, rather than deploying multiple models for this, what I am giving is like a single interface for those multiple problems that you are trying to solve. So although I am giving a single interface, you are able to solve multiple problems using that single interface. Although,
Anything very specific you can tell, like if it is a sort of customer interface, and if we take an example of Dr. Lal Path Labs. So, what would you suggest to them for their business to integrate the generative AI? In which section of their business you would love to integrate this AI?
see, for LLMs currently, it is in developing stage. So companies want to experiment with these because definitely they have potential, but they are also, they don't want to disrupt what they are building for years, for sure. But what they are doing is like they are picking one two problems and they are just, so for example, OpenAI GPT 3.5, anyone with some experience can use that. It's like you write a prompt and you send it to it and you get a response. So if you have something like that, you also have these image based problems. Image based LLMs are in very initial stage and they are not working as expected, but mostly in administration tasks. So for example, clinical note taking or summarization, those problems people are exploring LLM a lot. One more problem that we are solving at Kerlon is like there are a lot of data points scattered here and there. So knowledge management is also one of the big applications. So imagine if you have a lot of data and you want a single interface for that data. So something like that. So people are exploring right now. Also, vision is in very initial stage, but definitely like the field is progressing by a lot. So in next 6 months we will see better vision and all these. But if you ask my perspective, within a year or two, I see that there will be a single model uh, operating on this multiple modalities, whether it is a image or text or sequential data like protein as well.
Okay.
Yeah.
Last question from my side, that how the expense will be coming on to the end customer? But do you see this is going to be expensive for the end customer or the end user?
Definitely. I mean, like it depends. at what scale you want to do. Basically, these models cost you per token. So depending on what range of data you want to operate on. So yeah.
I'll answer your question in a two-part way. You basically asked that whether in any way AI can be helpful for a company like Dr. Lal Path Labs, right? So in that, like as per whatever I can imagine in their workflow, there can be two aspects. First aspect is the client facing side, in which the customer is asking for a service, right? In that, actually, the point is the investigations that you are getting it done, okay, they are mostly standardized. Not mostly, they are all standardized, okay. So the company itself doesn't incur any sort of risk in giving the investigation output to the customer, right? So there is nothing which is causing a health problem to the patient, right? So because of that, they will have the ease of, they can actually develop a chatbot sort of thing in which the patient just inputs that I am facing this, what investigation should I need? Okay. It can suggest the investigations, and after that, whatever the customer decides to do is their own responsibility. And on top of that, whatever they are ordering, okay, because it is like a business type of thing, right? You are just ordering and you are getting a service, right? So in that, there's no risk to the company also. So this way, this is one part in which they can sort of improve the customer experience through AI. The other thing that can be done is most of the investigations, they have a set limits. Like basically, your suppose hemoglobin comes out to be 10. Okay. There are normal limits known for the population which it is being served, right? So based on the multiple investigations that you have ordered, just based on those limits, you can come like this is the hemoglobin value, this is the volume of the RBC, this is the hemoglobin concentration, you have microcytic hypochromic anemia. Okay. And these type of diagnosis can be very readily made, which will not actually impact the patient's health. It will just give them more information, right? So that is the other side in which you are basically inputting the investigations, or basically part of the way in which they give the output. Like as a part of that, they can summarize the output. You have this, and this. Based on your investigation, kindly consult a doctor. Coming to the cost, frankly, I don't see there's much of a cost to this. Like most of the things that I'm speaking about are very well developed by now. Okay. So it can just be easily integrated directly. Right?
Thank you.
Thank you so much, Shyam, for a captivating session. It was very valuable. Thank you so much once again. A huge round of applause again for him. So now we are unfortunately come to an end of the session for the online viewers here. So before I end, I just want to thank our backstage team who are not visible, but their contribution is immense. So first I want to mention very talented, who is entirely doing single-handed live streaming. That is Bhushan. And of course, charming co-host Sanna. And beautiful Brikshi, who is totally handling the social media post. And yes, last but not the least, Shiril, who is responsible for the entire setup of this event. Thank you so much, and from bottom of my heart, it's very valuable, and thanks a lot. And yes, how can I forget all the audience who are a part of this particular thing? Thank you so much. So now we are just moving ahead here, self. Just a moment.